Hello everyone. So previously we had discussed on the topic digit DP algorithm. Yeah. So today we'll be discussing on the topic Bitmask DP algo. Yeah, Bitmask DP algo. So now let's get into the definition part. So what does it say here? Bitmask DP is useful when the number of elements n is small, typically less than or equal to 20, because we can represent every subset as a binary number of n bits. Yeah. Each bit is the mask represents whether a particular element is included in the subset 1 or not, or 0, basically subset 1 or 0. This is fine. Now, let's consider the example. Suppose for n equals 3, the subset is 1 to 3 actually. That can be represented as 101 in binary. Yeah, 3, we are just going with a 101 in binary, which is 5 in decimal, which is 5 in decimal. Yep. This allows to store DP states efficiently, right? DP of mask can store the answer for the subset, this one mask actually. So typical problems that can be solved with a DP, this one bitmask DPR. These are some of the use cases, right? So this one traveling salesman's problem, one of the important problems, yeah, one of the most famous problems as well. TSP assignment problems. So assigning task to the workers. So this is one of the most important problems that can be solved using the Bitmask DP. Yep, subset sum with a extra conditions. This one is as well. The key is basically transitioning from one mask to another by adding an element and updating the DP state, right? So let's go with the example problem. This one, assign n task to n people. We are assigning a number of tasks to the n people, number of people with a minimum cost. Yeah, with a minimum cost actually. Each person can do each task at a certain cost. We have to find the minimum or the minimal total cost. Yeah, this is fine. Now, uh, let's do one thing. Let's start writing the code. So this is one. Let's start writing the algo by making use of the Python programming language. So we'll be considering this problem actually. We'll be solving this one using the algo. Yeah. First, let's go with the people or tasks, man. So I'll just go with n equals 3 initially. Yeah, I'll just go with n equals 3. Next, let's go with the cost here. Cost, let me go with 9, 2, 7. So this is fine. Also, let me go with 643. This one will be 643. This is fine. The next one is, let's go with the, so we went with the cost for the person 0 to do the task 0, 1, 2. Yeah. Next, we went with the cost for the person 1. Now let's go with the cost for the person 2. Yep. So I'll just go with 5, 8, 1. Yep. So this is fine, I believe. So I'll just come out of this one entirely. Now let's initialize the DP array for 2 into n subsets that is filled with the infinity. So DP equals, so let me go with the float infinity. So this is fine. Infinity. Next, let me go with into 1 left shift n. So this is fine. Next, let me go with the DP of 0. Let me assign this one to the 0. So this is the base case, right? So when no tasks are assigned, cost will be 0 actually initially. Yeah, DP of 0 will set this one to 0, nothing but the base case. Now let's iterate over all the subsets of the task. So let me make use of the for loop here. For mask uh, in range. So what will be the range here? So 1 shift n actually. So this is fine. So within this for loop, so we have to count the number of tasks already assigned in this particular mask. So let me assign x to the bin of mask dot count here. This is fine. Count of let me go with 1, count of 1. So this is fine. So the next one would be here. We have to try assigning on and this one unassigned task j to the person x, right? So this one will be for j in range. So this one will be n. This is fine. The next one would be if not, if not mask bitwise and this one will be 1 less than j, 1 less than j, and also this is why we have written in this way actually, bitwise and this one left shift. So if task J is not yet assigned, then we'll be considering in this way. Now, let me go with here. Sorry, this one. Now within the if condition, let me go with dp of mask or this one left shift J here. This is fine. Mm, let me assign this one to the min of dp of mask actually. dp of mask actually. Yeah, mask or one left shift J. One left shift J. This is fine. Yeah, this is fine, man. Mm, this one will be dp of mask, dp of mask plus cost of xj, cost of x and j. This is fine. So what will be the final this one? Let's do one thing. Let's print something. Nothing but the final answer here. So minimum cost for all the tasks that has been assigned, right? So let me go with the print for the interactive purpose here. So this one will be dp of, let me go with one left shift n. So this is fine. One left shift n. So this one will be minus one. Yep. So this is fine. Yep. So when I run the code, the output that I need to get here is this one 9 actually. Yeah. When I run the code, the output that I need to get here is 9. So why I should get the 9? So we have the understanding of the algorithm. So whatever the code that we have written, right? See, I'll explain why we should get 9. First, person numbering here is x, right? We have made use of the x here. Person numbering here is x basically. Yep. So x is nothing but the x here is nothing but the number of tasks already assigned. Yeah. So this one I can just consider number of tasks that has been already assigned. Yeah. So this one will be number of tasks. Yep. Now, yeah, the dp of 0 initially we'll be setting this one to the 0. The base case we have already discussed, dp of 0 is 0 for the no tasks assigned. Now let me go with the masks actually. So initially, so let's go with the mask here, 0 0 0. So let me go with initially dp of 0 is equal to 0. Now we try assigning the tasks. First we will be going with the this one, 0 0 0. First we'll be going with the 0 0 0. Second we have to mask 0 0 1. Third we have to mask this one 0 1 0. Next we have to mask 1 double 0. Finally we have to mask actually, what do we call, not finally actually, so we have to mask 0 1 1. Next fifth one, the sixth one we have to mask 1 0 1, and the seventh one we have to mask 1 1 0. Yeah, the first one here would be this one, what do we call, masking triple zero, this one x, when x is 0 for the person 0, right? So what we'll do here for this guy, so we will assign task 0, nothing but dp of 0 0 1. So this will be minimum of infinity comma 0 plus 9. So this will be 9 actually, task 0 9. And we'll assign task 1 dp of 0 1 0. So this one will be minimum of I infinity 0 plus 2. So this will be equivalent to the 2. Next we'll assign task 2 dp of 1 double 0, minimum of infinity comma 0 plus 7, nothing but 7. So for this one we got 9 comma 2 comma 7, 9 comma 2 comma 7. So same thing we will be doing for the this one, mark 0 1 0 0 1 0 1 0 1 double 0 0 double 1 1 0 1 and double 1 0. For the second one it would be 13 12 actually. Yeah, for the second one it will be 13 comma 12. Yeah, in the same way for the third one it would be 8 comma 5. For the third one it would be 8 comma 5. For the fourth one it would be, it would lead to 12 comma 5 actually, it would lead to 12 comma 5, right? For the fifth one it would lead to basically 9 comma 2. It would lead to 9 comma 2, right? It would lead to only 9 actually, not 9 comma 2, 9. So for the sixth one it would lead to, for 101 it would lead to 9, and for the seventh one it would lead to 9. So this one, the last one, will be considering this one as the output. Yeah, for the final one, dp, actually we have to go with a dp of 111 actually, dp of the 111, right? So finally, this one DP of final DP will be considering actually DP of this one. So we will be going with a basically 9. Yeah, we'll be going with a 9 actually. This is fine. Now, let me show you the minimum correct assignment actually. So this we now know how we got the correct output 9 actually. This is fine. So correct minimum assignment here is, first let's consider the person 0. So we will be going with the task 1. We'll be assigning the task 1 which is of the cost 2, which is of the cost 2. Next what we will do, we'll be going with the person 1 will assign task 0 which is of the cost 6, which is of the cost 6. And person 2 will assign this one task 2 which is of the cost 1 actually. So this one will be basically we have to add up the cost 2 plus 6 plus 1, 2 plus 6 plus 1. So this will lead to 9. So the output that we need to get here is 9 basically. Yeah. So the output that we need to get here is 9. I hope this part is clear, man. Let me come here. Let me give Control J. Let me give here Python followed by file name. What did I give, man? Oh my God. So I'll just give here Python. Give me a second here. So let me copy the entire file name, file name.py. Yeah, so we are getting the output 9, which is absolutely correct. We are getting the desired output, right? So this is fine, I believe. So this is it for the algorithm. So this is it for the Bitmask DP algorithm. Yeah. So let me summarize whatever we have learned so far. So we are done with the Bitmask DP algo. Let me summarize whatever we have learned so far. Just try to remember these 4 to 5 points, man. This is very important. Yeah. So the first point here is Bitmask DP represents subsets as binary numbers for the efficient state storage. For the binary, it basically represents binary numbers. Bitmask DP represents this one. What do we call? Subsets as binary numbers. Binary numbers for the efficient state storage. So this is fine. The second point here is, so this is ideal for the problems with less than or equal to 20. This is ideal for the problems with less than or equal to 20 elements, and subset depends on the states, and subset depends on the states. So this is fine. And the third one here would be, so what are the key steps here? We will be masking. So we can make use of a mask actually, or we can make use a mask to represent the assigned elements. Let's make use of the mask to assign the to represent the assigned elements, right? To represent the assigned element. So this is fine. Yeah, to represent the assigned element. So this is fine. And also let's iterate through the masks. Let's iterate through the masks actually. Let's iterate through the masks and update states for the new assignments, and updates states this one, and update states for the new assignments, right? So this is fine. So this is one of the important things. Next one, common problems or the use cases are, we have already discussed this one, traveling salesman problem, assignment problems and the subset problems, assignment problems and the subset problems. So this is fine. The final one here would be, this approach reduces the exponential looping over permutation to manageable big of n square, this one, big of n into 2 to the power of n. So I can just write it on this one, big of n into 2 to the power of n, sorry, n into 2 to the power of n complexity. This approach reduces the exponential looping over permutations to manageable big of n into 2 to the power of n complexity. Yeah. So these are some of the important points I found. This one I wanted to discuss with you guys. Yep. Now we are done with the Bitmask DP problems. Yeah, we are almost at the end actually. So we are left with only one algo that I want to discuss here. That is nothing but the this one, DP on the DAG, nothing but directed acyclic graph. So that is one of the important DPs. So from tomorrow, we'll be starting with greedy algorithms as well. One algorithm is left in the DP, nothing but DP on DAG, and we'll start with a greedy algorithm. We'll be going with the activity selection problem or the algorithm, right? So tomorrow we'll be finishing with the this one, DP based algorithms. Yeah. So this is fine, I believe. 13 important algorithms we have discussed here. 12 including this one, yeah, including this one we have already discussed 12. So tomorrow including the last one, it will be 13 actually. Yeah, so we'll be done with the DP based algorithms. As I've said, tomorrow we'll be starting with the this one as well, what do we call, greedy based algorithm. Yeah. Now I hope the Bitmask DP algorithm is completely clear, right? So yep, for now this is it. Thanks for watching, guys.